All right, in today's mini lecture, we're going to add and subtract rational expressions. And this is called part one because part one will discuss expressions with like denominators when the denominators are the same. And in part two, we'll go ahead and discuss unlike denominators. So there are a few steps that we must first know. When we see like denominators, we're going to add or subtract the numerators. We're going to keep that denominator the same. Since they're both the same, we're going to write them over that one same denominator. And then after that, simplify wherever needed. So let's go ahead and start off with an example. I'm going to do an example that you're probably familiar with, something similar to what you've done in elementary and middle school. If we have something that says 7 over 16 plus 8 over 16, right? And here you see that the denominators are the same, right? The denominators are the same. So I'm going to write them over that 16 because they're the same denominator. So here at the top, I'm just going to show the steps for this one problem, right? 7 plus 8. 7 plus 8 is 15, and then we have 15 over 16. Well, we can't simplify or reduce this any further, so this will be our answer. So understand, if this were a subtraction problem, we would just go ahead and do the subtraction. I just did this problem to show how this is so closely related to subtracting and adding rational expressions with like denominators. Let's go ahead and take a look. Another example may say 6 over x minus 5, right? And then here we have plus x plus 2 over x minus 5. So you're looking at this and you're saying to yourself, okay, they have the same denominator. When they have the same denominator, we're kind of on easy street a little bit. We write them over that same denominator, x minus 5. And now we're told to add. It's an addition problem, so we add 6 plus the x plus 2. The like terms are the 6 and the 2. So we'll have x plus 6 and 2 make 8 over x minus 5. There's nothing we can do here. We can't reduce or simplify any further, so we go ahead and box in that answer. Let's go ahead and take it to another type of problem. Our problem now looks like this. Let's say we have x squared plus 3x minus 2 over x plus 5, that product right here in the denominator, and x minus 2. This is being added to this rational expression 4x plus 12. And this is over x plus 5, this product again, over x minus 2. So again, we see the addition of these two rational expressions, but no worries because they have the same denominator. In that case, them having the same denominator, I'm going to write them in my next step over that same denominator, x plus 5 over x minus 2. And I'm told to add these two polynomials, so I'll write it out this long way, x squared plus 3x minus 2, and add that to 4x plus 12. And now we take it back to addition and subtraction of polynomials. What do you do? I'm going to show a lot of steps here. X squared plus 3x. And understand that you can skip a lot of these steps on your own once you get used to doing this. When you add two polynomials, you drop the parentheses and then write the second polynomial out. After this, I'm just going to write it above its singular denominator. And now go back into the numerator and just combine any like terms. So what like terms do I have? Well, x squared doesn't have a like term. However, the 3x and the 4x, they're like terms. So that gives us 7x. And then that negative 2 and positive 12 gets us a positive 10. And that's all over x plus 5 and x minus 2. All right, what's next? We're not done yet, because if you take if you go back up, rewind a little bit, you'll see that that third step said to try to simplify. We would just try to simplify wherever possible. And how do we simplify? Well, in understanding simplifying rational expressions, we know we need to have everything fully factored. Well, this numerator needs to be factored. The leading coefficient is a 1, so I can go ahead and use this product sum method, or some of you may use a trial and error method or some type of box method, whatever method is comfortable for you. So for myself, I'm saying what times what will give us positive 10, and the same two numbers that I'm multiplying have to add or subtract to make positive 7x. So to me, that's 5 and 2, right? Positive 5 and positive 2 make positive 10. Positive 5 and positive 2 added together will get you that 7x once we go through the foiling and stuff like that. And that's still all over the denominator of x plus 5 times x minus 2. And in simplifying, the x plus 5's cancel out, and we're left with x plus 2 over x minus 2. There's no more simplification we can do. That is our answer. All right, let's try one more. Let's scroll up a little. And my next problem will be x squared minus 2x plus 3 over the denominator of x squared plus 7x plus 12. And now we're doing a subtraction. Minus x squared minus 4x minus 5 all over x squared plus 7x plus 12. So it's a subtraction, but no worries, we're still doing the same thing we've been doing. We see that the denominators are the same, so we're going to write it as a single fraction, all over x squared plus 7x plus 12. So now I'm taking that numerator of the first rational expression and writing x squared minus 2x plus 3. And I'm going to subtract that other numerator on the right, x squared minus 4x minus 5. And then we have to think back to adding and subtracting polynomials and say, okay, what did we do when we subtracted? Well, you're told to think of it in one of two ways. This minus sign you can think of as a -1 and multiply everything through times -1 and write it down. Or you can say, okay, this minus sign turns everything in the parentheses to their opposites. So however you think of it, you're going to get negative x squared plus 4x plus 5. All right, after that, I'm going to still have it over that one same denominator. And now just combining like terms. So I have x squared and x squared, negative x squared, I'm sorry, that makes 0, right? X squared minus x squared makes 0. Negative 2x and a positive 4x, that gives me 2x. And positive 3 and positive 5 gives me positive 8. All right, now I need to go ahead and try to simplify, so I need to go ahead and factor that 2x plus 8. Well, the first step in factoring is always to look for a greatest common factor, a GCF. From 2x and 8, their greatest common factor is a 2. That's what they have in common, right? 2. The 2x and the 8 have both a 2 in common. So 2 goes into 2x, x times, 2 goes into 8, 4 times, and I'm writing it above this factored denominator. So now I'm going to go ahead and try to factor this. I'm saying to myself, what times what makes 12? And the same two numbers have to add or subtract to make 7. So that's plus 4 and plus 3. And now I see the x plus 4's can cancel out. When things cancel, they leave 1's, of course. So 2 times 1 is 2. 1 times this x plus 3 is x plus 3. There's no more simplifying I can do. So we would stop right there. So again, this all was adding and subtracting rational expressions, and it's just like adding or subtracting fractions with like denominators, because as you saw, these rational expressions had like denominators. So we had to remember to go ahead and write them as one single fraction, and then go ahead and perform the addition or subtraction according to the rules for polynomials, in addition and subtraction, excuse me. And then go ahead and simplify wherever possible, cancel out if needed, and then we're left with our final answer. All right, in the next video, part 2, I'll go ahead and show how to do addition and subtraction with unlike denominators. So you can move on to that if you're done with this. Remember to like the video if it's helped you any, share with any friends or family members who may need it as well, or classmates as well. And don't forget to subscribe so you can be notified of new videos. And feel free to shoot me an email if you want a certain topic with a mini lecture to go with it. Take care.